was to show you on our Canvas page, integration formulas. All of that is right. Is this what you're talking about? It's all right here. You got 4 pages of it. And I will provide this on the test. I don't have any here to give you, but you can print it from there. All right? Or pull it up on your phone or your tablet or whatever. You get it right there. Just go to our Canvas home and integration formulas right there. All right, number 11. That was the next one, correct? Was that his question?
Yes.
That's yours, number 11? All right.
Yeah, I got that one too.
So let me erase the board. Okay, so we need to determine if this converges or diverges. So if you look at it, we have a k to the 5th in the denominator and a k in the numerator. That's like k to the 1. So that's a difference of 4, right? What do we suspect? What's our hunch? Is it going to converge or diverge? There's a difference of 4, you got 5 in the denominator, that's like, it's going to behave like this, 1 over k to the 4th. What's p-series say about that? Converges, right? The p-series would say, because 4 is greater than 1, okay? So, our hunch is that this thing is going to converge, not diverge. So we need to prove convergence. Well, that's not, ratio test, root test, it doesn't work for p-series. We could do the integral if we can find one that's nice. None of those are going to work out nicely with this problem. So when nothing works nicely, we think about convergence test. I mean, not convergence, what am I saying? The comparison test, all right? We compare it to something that we know converges and that this is less than. Well, don't we know that k over 8k to the 5th plus 1 is always going to be less than k over k to the 5th? Don't we know that's going to be true? The numerators are the same, but this denominator is always going to be larger than that denominator because we're multiplying by 8 and adding 1. So if that denominator is always going to be larger than that denominator, this fraction will always be less than that fraction, correct? So we know this is always less than this, and we know that this is equal to 1 over k to the 4th, which we know converges by p-series. So if this converges by p-series, and this is always less than that, and it's always positive, this has to converge, doesn't it? No possible way it could diverge. So, we say that this sum okay, everything I said here was true, but this one is easier than that. I wasn't thinking. This one's alternating, isn't it? We don't have to do that. that was true, and it would prove this converges. There is an easier way. I was not thinking about the alternating part. All right? Alternating series test. The limit as k goes to infinity of this expression, k over 8k to the fifth plus 1, equals what? We have a polynomial in the numerator, a polynomial in the denominator, and the numerator is of less degree than the denominator. The limit is always
0.
0. And what does the alternating series test say if that limit is 0? Converges. That idea only works when it's alternating. If it's not alternating, then this would be inconclusive. All right, so now let's look at this. If the alternating part was not there, then we would have done this and used comparison test. Okay? You guys got that? If the alternating piece was not in it, we could do this. And if it asks about absolute convergence, we would use this.
For the, when we're doing it on the test, does it matter which one we use?
As long as you do it correctly, I will accept it. Unless the directions specifically say use a specific test.
And what did you say that about the alternating series when there's a polynomial on top and the bottom?
When you're doing this limit,
Yeah.
if the numerator is of less degree than the denominator, it's always 0. If they're of the same degree, like if that was k to the fifth, then it goes to the ratio of the leading coefficients. If the numerator is of greater degree than the denominator, like that was x to the seventh or something, then it's infinity.
So that would be 1 over k to the fourth. The leading coefficients would reduce to 1 over k to the fourth, which is 0.
No, well, because of the plus 1, you can't do that.
Oh.
Yeah, because of the plus 1, you can't do that. Hold on, I'm turning myself up louder here so I can hear better.
Well, I thought we could disregard that part.
No.
When you're doing divergence test, or forget.
In terms of doing a limit, I guess you could, but you can't disregard it in terms of proving this is converging.
Okay.
Okay. All right, so let's look at our options in here. All right, the series converges because for any index n, there are some values k greater than n for which a sub k plus 1 is greater than a sub k, and some values of k greater than. I don't believe A makes any sense. B, the series converges because a sub k is non-decreasing. That would mean it's increasing in magnitude for k. No, that doesn't work.
It's going to be F.
Series diverges? No, we said it converges. Diverges? No. Diverges? No. So F. The series converges because a sub k is non-increasing. That's true. In magnitude, that means like absolute value. For k greater than some, and the limit equals 0. So that basically describes the alternating series test, that statement there. All right? Basically describes the alternating series test. Is that okay? Are we okay? All right, other questions?